Welcome to this lesson video. Today we'll be looking at free body diagram. Let us start. Free body diagrams normally they indicate how many forces are acting upon an object. Now let us look at the first scenario. We have this object on top of a flat surface. Now this object is stationary. Since this object is stationary, we have four forces which, in terms of magnitudes, they cancel each other. Now for example, the first force is our normal force, this direction. The second force is equal in magnitude with the normal force but opposite direction. That is force of gravity. So since force of gravity and normal force, they are equal in magnitude but opposite direction, it means they will simply cancel each other. Our vertical sum of forces is equals to 0. Now the second one is this one. You may see this is force applied, opposite direction it's this one. So drawing our free body diagram, it's going to be like this. A dot represents an object, and then we have normal force, we have gravity, we have applied force, we have friction. Then we simply label them. That is the free body diagram of the first scenario. Our second scenario, we can see we have an object which there's a person pushing the object. The direction of the object is to the right. Now, what is the free body diagram? And the surface, it's rough, it's not frictionless. So the free body diagram, as usual, a dot represents an object. We have normal force, we have force of gravity, we have kinetic friction, and then we have our applied force. Now you can see the applied force is a bit longer than all these forces. It simply means that force of applied force, it's the one which is causing this object to move to the right. So the resultant force is to the right. Our next example is similar to the previous one, but then the surface is frictionless. There is no kinetic friction. So the free body diagram, it will be normal force, force of gravity, applied force. There is no kinetic friction. Our next example, we have this object. It's moving to the right. There's no applied force, and then the surface is frictionless. Now, how do we draw the free body diagram? Since we don't have any applied force and kinetic friction, so the only forces which are acting on the object are only these forces. In this example, we have an object moving to the right where the surface it's rough, there is friction, but then there's no force applied. What is the free body diagram? This is our free body diagram. Our next example, we have an object on top of an incline. It's sliding down and the surface of the incline is frictionless. What is important in this particular scenario? You must know that the gravitational force is always pointing downwards. It doesn't matter whether the surface is flat or inclined. The gravitational force is always vertically downwards. And then our normal force, it must be perpendicular to the surface. So the direction of the normal force depends on the surface. So if the surface is inclined, it will be perpendicular to the incline. If it's flat surface, it will be perpendicular to that flat surface. Now, since we said there's no kinetic friction and then there's no force applied, so it simply means that we have two forces acting on the object. The first one is gravitational force, this direction, and the normal force, this direction. Our next example, we have an object on top of an incline, and then the object is being pushed up. The surface is frictionless. Now, how many forces are acting on the object? This is our free body diagram. We have gravitational force, we have our normal force, then we have our force applied. Our next example, we have an object is being pushed up. This is the direction, it's going up, and then the surface has friction. Now, what is the free body diagram? Fg, normal force, our force applied, and our kinetic friction. Our next example is similar to the previous one, but you can see that the object is being pushed downwards, and then the surface has friction. So our free body diagram will be like this. Normal force, Fg, applied force, and kinetic friction. This particular example, we have an object on top of an incline which is rough. There's no force applied, it's sliding down. The free body diagram. Normal force, gravity, and Fk. Sometimes an incline might be like this. So the free body diagram, the normal force will be this direction. Remember, it must form 90 degrees. So we have gravity, and then we have kinetic friction. Our next example, it's an object which is connected with the ceiling, and then it's connected using a rope. Now, what is the free body diagram? How many forces are acting on this object? Now, whenever we have a rope, we must think about tension. So what is the direction of the tension from the object to the rope? Is this direction. The direction of the tension from the ceiling to the rope is this direction. We are only interested on the object. So this will be our tension, and then this will be our Fg. So the free body diagram will be like this. Our next scenario, we can see we have two objects connected by rope. One of the objects is on top of a flat surface, and then the other one is hanging. Now suppose this is object A, this is B. So the free body diagram of A, the system is stationary, by the way. So we have normal force, we have force of gravity, we have tension. This is for A, and then for B, we simply have tension and force of gravity. Our next scenario, we can see that it's similar to the previous one, but this one, the system is moving to the right, referring to the object A, and then obviously object B will be going down. Now what is the free body diagram of A? It will be tension. By the way, the surface is rough, so we have kinetic friction, we have normal force, we have Fg. This is A, and then B, we have Fg and tension. Our next example, we have two objects, one hanging and then the other one on top of a surface, and then there's a force applied to the left. The system is moving to the left, referring to block A, and then referring to block B, it's moving upward. So what is the free body diagram? The free body diagram of A, it will be force applied, it will be normal force, it will be gravity, we have tension, and then we also have kinetic friction. And then for B, we have tension, we have gravitational force. Our next example is similar to our previous one, but then this one, the force is applied at a certain direction, and the displacement of the system is not in the direction of that force applied. So what is the free body diagram? This will be our Fg, our normal force. This will be our F, and then this will be our kinetic friction. And then we also have tension. For B, we have tension and Fg. Our next scenario, we have an object which is connected by two ropes. And then what is the free body diagram of this object? We have our gravitational force, and then this you may see this is tension number 1, this is tension number 2. A similar scenario, but then we have another object connected by a rope with the first object. Now object number A, actually object A, it's, we have tension T1, T2, and then we have Fg, and then we also have another force which is, you may say this is T3. Then for B we have T3 and Fg. Our next example, we have an object connected by two ropes. You can see from the top and from the side of the walls. Now how do we draw a free body diagram? We have Fg, we have T1, and then we have T2. This is our next scenario. We have two blocks, and then we want to draw free body diagrams. For block A, we have Fg, we have normal force, we have tension. For B, we have Fg, we have normal force, we have tension. Our next example, we have two blocks connected by a rope. Let us draw free body diagrams. For B, it's tension and gravitational force. For A, we have tension, normal force, and force of gravity. Okay, that's it for this lesson video. I hope it is helpful. This is Wahula SJ. Thank you very much.